Well, welcome everybody to the Practical Data Lunch and Learn. Today we have Hamilton Ulmer. Is that how you pronounce your last name?
That's right.
Spot on. Cool. So what got Hamilton here is last month at Data Council. Hamilton, apparently, I wasn't there, but he unleashed something called Instant SQL, which got a lot of buzz. So in the spirit of the practical data community, why don't we just bring Hamilton in and you can show off what he created? So it seems like you're really stoked on it too. So this is, I think you're gonna bring a really fun time to this. But yeah, anyway, take it away. Feel free to introduce yourself and do your thing.
Sure. Well, thanks for having me, first of all. My name's Hamilton. It's nice to see everybody here. I'm the I'm the UI lead at MotherDuck, and MotherDuck is a data warehouse built on top of DuckDB, and all of that's relevant to this talk. And so I have some slides. Can I just share my screen and we can just jump in? Cool. Great. So let me share real quick. And awesome. Okay. So I work at MotherDuck. MotherDuck's a data warehouse. You write SQL to query the data warehouse. So today we're going to be talking about SQL, our dear friend. But this talk is really about what it takes to build tools that might be complex, that might require mastery, but also are fun to use and encourage a flow state, kind of like playing an instrument. So let's talk about recording studios. So in a previous life, I produced and arranged music for artists all around the United States and worked in tons of recording studios. I had a blast doing it. And it was some of the most fun I had in my entire life. And at the center of the recording studio, this talk is about software, is this little piece of software called the Digital Audio Workstation, or DAW. Now, the point of the DAW is to help orchestrate all of the input signals from microphones and all the equipment in the recording studio into recorded digital audio tracks, and then kind of mix them together into a like semi-finished product. And working in a DAW is awesome because everything you do, you get an instant preview of the change that you just made. You can solo individual tracks and just hear little bits of audio. You can loop them. You can change all the parameters of your plugins from EQ to reverb. It doesn't matter. Everything is met with basically an instant reaction. And this makes producing music super fun. It also makes it really fun to get good at producing music. And so it's one of the kind of cool insights of software like this is that things that have instant feedback just become easier to master and more fun in general. So when I moved into the tech industry and began working on these sort of complex data analysis UIs, I found myself kind of missing that experience of what it was like to work in a DAW and to produce music. So this quote from Father John Colkin about Marshall McLuhan, who wrote The Medium is the Message, and it is, we shape our tools and thereafter our tools shape us. So when you spend years and years in a tool, it often changes the way that you actually think about the work and about the world. And I think that was the case with me and DAWs and music production. So let's talk about SQL. So of all of the ancient programming languages, SQL has had kind of the most interesting success trajectory despite decades, and I really mean decades of criticism about the language design. SQL has endured. In fact, it's actually thrived despite it all. And in part, this is because databases have always kept up with the times, right? Database technology has been progressing beautifully for decades through technological pressures such as the internet. The sheer amount of data that is generated from the internet has created new pressures on databases, and also now AI as well. And so databases have always been good at modernizing and keeping up with the times. And they've even pushed SQL as a language in its own way to meet the needs. But the interaction model of SQL has been stuck in the 70s. You still basically write your query, hit the run button, wait, and then respond to the changes over and over again. And as somebody who's done music and is used to that sort of instant feedback of the digital audio workstation, it's kind of jarring, actually, because writing SQL and running it, it breaks flow, right? I'm constantly waiting. My attention's constantly shifting. It's actually really hard to debug, unlike the digital audio workstation, where it's super easy to isolate exactly what you're hearing and tweak things. And then ultimately, because of these two things, it just does not spark joy. So let's walk through a few examples. Most common one, you're met with an empty SQL editor and you're drafting a new ad hoc query from scratch. So you begin typing, write out something, wonderful stuff, hit the run button, you get an error. Okay, great. So you realize you have a silly syntax error, fix that, hit the run button, get another error, fix that, and then you hit the run button and you wait. And then finally, you get some sort of result set. And this is the moment that your brain moves into analysis mode, right? You look at that column and you think, what on earth is even going on here? You realize you had reversed these. And so you flip that, fix it, hit the run button, wait, and so on and so forth until you finally get something that matches what you actually care about. So this is what that process looks like in the abstract, right? You write, you wait, and then you debug. Writing and debugging are these wonderful active activities, right? That's kind of the fun part of data work. Waiting is not. Waiting is passive, right? Every time we ask our brain to wait, we are asking it to spin a plate on a stick in your head, and that's exhausting. And if you're only writing or running queries a few times a day, it's not such a big deal, but we're doing this in the process of writing a new query hundreds, maybe even thousands of times, right? And of course, all that wait time does compound. But I think even more problematically, it's exhausting to the brain. Like, we haven't evolved as a species to wait for SQL queries to run. Now, again, to the credit of database engine makers, especially OLAP database engine makers, they've done a good job of reducing this wait time, right? But all the same, even a little bit of wait time is just enough time to get distracted by social media or the internet. So that's just writing a new ad hoc query. What about this problem? You are working at a company and your colleague leaves, and you have now inherited one of their massive SQL queries that is important for a production workload in some way. And you're tasked with debugging the results in one of the columns. So this query has tons of CTEs, lots of intermediate transformations. So you start by just kind of reading through the query bit by bit until finally you just give up and start commenting out whole parts of your query just to isolate the CTE that you care about. CTEs are awesome, but they're just really hard to debug. And they're so hard, in fact, that the popular BI tool Hex has a whole blog post about how you shouldn't use CTEs because they're hard to debug. And if you've ever used Hex, it's cool. It's a notebook, basically, and you can chain together SQL queries in a bunch of kind of notebook cells and use that instead of CTEs. And that's like great if you use Hex, but it makes me kind of sad because there's nothing like inherently wrong with CTEs as an idea. The problem is we don't have the tooling to actually debug them. So another example, how many times have you had this situation where you get a result set back and the column is just full of nulls, and then you realize, oh, wow, I have to basically break apart this complex column expression and figure out what exactly is going wrong. It could be the underlying data, could be the logic. There's no way of doing this easily. Really, SQL completely lacks good debugging tools. Essentially, the way we debug, it's always the same. It's just to write more SQL. So that's it for humans writing SQL. Things get a lot trickier when you add AI to the mix, right? So imagine you have a simple SQL or AI assistant where you highlight text, basically prompt it to rewrite your SQL in some way, and it makes a suggestion. So you can accept the suggestion, then run the query, and then debug it. If you've ever done this in practice, it's kind of terrifying, right? We've essentially taken this non-deterministic output from the LLM and attempt to shove it into our extremely fragile, unobservable SQL query. One misplaced comma could lead to a join explosion that might take hours to debug. It's a real nightmare. I think there's something wrong that we can't really make the best of this moment in AI because the tooling on the SQL side isn't really good enough. It really gets in the way of vibe coding. So I'm picking on SQL. I'm picking on the interaction model, but I love SQL. So the question is, can we do better than this? What does it mean to do better than this? So for that, I'm going to turn to Brett Victor, who is a researcher who gave a talk called Inventing on Principle. And in that talk, he stipulates his thesis for good tools. And I'll read it here. Creators need an immediate connection to what they create. And what I mean by that is when you're making something, if you make a change or you make a decision, you need to see the effect of that immediately. There can't be a delay and there can't be anything hidden. Now that is awesome. That sounds like a rubric to me, right? Digital audio workstations, they have this in spades, right? There's no delay. I'm getting an instant preview of everything that I'm interested in and nothing is hidden. I can solo individual tracks. I can really break apart the entire session in any way I want to figure out what's going on. And it makes sense that digital audio workstations work like this because in a way they're the whole point of them is to model a real world physical system, which is the recording studio. So recording studios have a bunch of analog circuits in place and recording onto tape was the norm, right? And that is instant feedback for a process that itself has instant feedback, music, right? You hear music as soon as it is made. So it makes sense. This is modeling a physical system, right? And I think it's easy for us to fall into the trap that because data transformation is not an inherently like physical endeavor, that we don't need to demand the same kind of physicality out of the tools, right? So given that, why hasn't anyone tried to do this with SQL yet? Why hasn't anyone tried to make a zero delay, nothing hidden system? So let's take each one of these and talk through them. The first is there can't be a delay. What does it mean for there to not be a delay? Well, here's my thesis. I want to get a result set every single keystroke. What that means is something like I need to get a result set every 50 to 100 milliseconds. That's what it means for there to not be a delay. Now, that's kind of mind-boggling when you're thinking about SQL queries in data, right? Because we are used to working in systems that are designed to make us wait. And we got very used to waiting all the time, right? But having this as a requirement basically rules out a ton of database systems already, right? Because part of that wait process is sending your query to a data center and then waiting for the result to come back. That network tax, the time it takes to actually go across the network, even if your database is almost instantaneous, that's not negligible. That's going to break our kind of keystroke fast requirement. So we need a database that sits on our computer right under our keyboard, is really fast, and has great SQL. And so with those requirements, only one database really for me stands out above the rest, which is DuckDB. So most of the people here are probably familiar with DuckDB, but if you're not, it's an in-process database, kind of like SQLite for analytics, does a lot more than that, and it's incredibly fast. It uses all of your cores to crunch down data. The fast part is, I think, the first thing anyone really says about DuckDB. They're kind of surprised that you're able to query CSVs as fast as you can. And so DuckDB's performance characteristics are really nice. And because it's local, it means we don't have a network tax. All of that's awesome. And it means something like this, right? Our queries can return, here's a really simple one, really, really fast. So we know that DuckDB is theoretically capable of getting the kind of latency that we care about. So can I run DuckDB queries on every keystroke? You can if they're simple like this, but you can't if they're real, right? Real world queries have CTEs, they've got joins. And to DuckDB's credit, it's still incredibly fast when you run these queries, but it's not quite keystroke fast. So we can't just like duct tape together DuckDB in a SQL editor to get what we want. In fact, we have to go kind of deeper than that. And so this is the point where I began thinking as a tool maker, how far can I actually take this? Is it possible for me to analyze this query and then rewrite it so that it's fast and still gives accurate previews? Well, to do that requires a whole bunch of different things. First thing is the database parser. I need to parse the query so I can understand its semantics. Now, this is kind of cool because DuckDB actually exposes a scalar function that when you pass in a query as a string, it'll give you the abstract syntax tree. What that means is that I have a way to programmatically understand the nature of this query in a really deep way. And so I can perhaps use this to rewrite parts of my query so that it'll be faster and still get a preview that is useful for the actual modeling of the data. It turns out we need something like this because not every DuckDB query is actually fully local. Sometimes my data source might be in S3 or in some other location, and running this on every keystroke would also be slow, right? So combining these two facts, my data may not be local, and I need to rewrite my query so that it's always fast, so that the logic makes sense. Gives us something kind of like this, right? The top is the original query. Imagine that we just cache the from statement and provide a limit. And then we rewrite that query again to have a different from statement. This is sort of the like basic, most naive version of how we could actually use DuckDB for both a local cache and also for rewriting to make kind of keystroke fast, a keystroke fast sort of preview system. And that's great. It gets us back to something like this. But if you're paying any attention, you know that this is not always going to yield what you want, right? I might have where clauses. Is my where clause against the cache version, or is it against the remote version? And so that's actually where MotherDuck comes into the picture. So I work at MotherDuck. It's a cloud-hosted DuckDB. Basically, it's a data warehouse kind of powered by DuckDB. And MotherDuck has this architectural piece called dual execution. And what it means is that you have your local DuckDB instance running on your computer, and MotherDuck has a server-side DuckDB instance, and that's kind of close to where your MotherDuck database is. And so we can choose how to split up computation so that your local database is doing work when it needs to do it, and MotherDuck is doing a lot of work when it needs to do it. And this actually makes all the difference here, right? And so what I can actually do is use the MotherDuck server to cache, and then once that I have that, I use the MotherDuck server to filter out the data of my where clause and then cache that locally and then rewrite to get that kind of keystroke fast response. And it turns out this makes a huge difference because having a beefy server on the other end means that I can get way more efficient scans. And it means I can also get things like table sample pushdowns, which is incredibly helpful. So that's some of the kind of high level details about how we deal with the delay problem. Basically combining DuckDB along with its parser, along with MotherDuck's dual execution, gives us the possibility of creating a system without delay. By separating out caching from rewriting and using essentially a different instance of DuckDB for each, we can get really awesome performance characteristics across the board. And once that data is cached locally, it's easy to make things keystroke fast. So let's talk a little bit about how we expose things that are hidden. Now, what does this even mean for SQL, right? My background is in data visualization, and there's this very well-known researcher named Ben Schneiderman who wrote a paper called The Eyes Have It. And in that paper, he outlines his visual information seeking mantra, which is this: overview first, zoom and filter, then details on demand. So normally when I give this talk in person, I make everybody chant it. And once you're done chanting it, congratulations, you're a data viz expert. So I recommend after this, just go turn off the lights in the room you're in, lay on your floor, and just chant overview first, zoom and filter, then details on demand. So what does this actually mean for SQL? What would it mean to apply the idea of zooming and filtering on a SQL query, or getting details on demand? Well, really the most reliable proxy of a user's attention in a SQL query is the cursor location. The cursor location is where the person is thinking about writing the SQL. It's where the attention is. So maybe there's some way to use the cursor's location along with this very minimal positional information we get from DuckDB's parser, combined with the tokenizer to get this, which is a path through the abstract syntax tree. This way, I know semantically perfectly at any level of fidelity where the cursor is in the query. For instance, I know that this is in a column ref, which is itself potentially in a function. Well, actually, in this case, it's not in a function. It's just a column ref, which is part of the select list, which is part of a select node. Having this path is a massive unlock around the UX of writing SQL. So I'm going to walk through a few examples of what this kind of parser-powered query intelligence can get you. So the first is pretty simple. It's just semantic syntax highlighting. As I move my cursor on the left, you could see on the right the path through the abstract syntax tree. When my cursor goes toward the joins, you could see actually that when you write joins like this, it actually creates a one-sided tree all the way down. My cursor is going through any part of an expression will light up the part of the expression that it actually references. And this is like cool. It's not necessarily super useful just on its own, but it really shows you how much power you have over understanding the query. Most tools lack something like this, most SQL editors, at least at the level that we have it. So here's something totally contrived. I'm just taking the columns of my select list and I'm shuffling them in place. Not very useful, but you could see that possibilities here, right? I'm shuffling it perfectly in place and none of the text above or below is changing at all. So maybe something a little bit more useful. I've got my cursor in a column expression in the select list, and I'm essentially just using an AI model to generate an alias based off of the expression text. Super easy to just not only pull out that exact expression text, but also rewrite the query in place. Similarly, I could have a simple kind of menu pop-up that allows me to turn the current select statement into a CTE, name it with an AI model, and then continue my data modeling. Kind of keep you in your flow. When you finish your first transformation, you're ready to kind of move on to the next part of it. Really, really nice. So those are just some examples of how we can essentially use these ideas from Ben Schneiderman around zooming and filtering and details on demand, at least that provide some ingredients to make things less hidden. And so, okay, we've got our ingredients, we've got the recipe. What can we make out of this? Like, what are we actually building for? So the whole point of this is to go back to my gripes with SQL, right? And enable people to get into a flow state, to make it really easy to debug. And while it still requires mastery to write SQL, hopefully it's fun, like playing an instrument. So all of these pieces combined went into a feature that we built at MotherDuck called Instant SQL. So I'm going to switch tabs and share a different screen now and show you some examples. Okay. All right. So this is the MotherDuck UI. I'm going to zoom in a little bit here so it's a little easier to see. I'm going to show you some examples of Instant SQL in action. So this is going to be targeting a MotherDuck share, which is just essentially a shared database in MotherDuck's architecture. I'll show you this in MotherDuck, but this actually works in DuckDB, just normal DuckDB as well. If you've used the DuckDB UI ever, we built the DuckDB UI, and Instant SQL is currently in that as well. And so you can just type DuckDB-UI if you're on DuckDB 1.2 on the CLI, and it'll spin up a UI. And you can try Instant SQL there as well. I'm going to show you it with MotherDuck just to show you a few additional things as well. And so today I think we're going to model, we have sample data. I'm going to show you the beloved taxi data set. So first things first, let's take a look. I may need to refresh because I've had this tab open. Oh, no, we're good. Okay, great. So the taxi data set, New York City taxi rides, beloved data set. First thing I'm going to do is actually turn on Instant SQL and begin typing from nyc.taxi. So essentially, as I'm typing, caching happens automatically. So I'm now actively modeling this data per keystroke. And you can see all the different columns. I popped up our column explorer feature as well, which gives us both obviously the names of the columns, but also distributions and null percentages as well. And so let's just start selecting some columns. Awesome. Oh, TPEP drop-off time. There we go. Great. So as you can see, I'm typing and things just kind of happen naturally. Ooh, passenger count. That sounds good. And what else? Okay, actually, this is super interesting. Let's look at fare amount. And it looks like there's also something called total amount. Can I compose fair amount with total amount? Let's see, tip amount plus tolls amount. So again, as I'm typing, everything just sort of interactively updates as I go. What else can we add? Plus improvement surcharge, great. Oops, it needs to be minus, awesome. Okay, so that's great. I probably haven't gotten all the columns here, but you can see there's a huge discrepancy between total amount and this assumed total amount. We'll call it that for now. Those don't look like they match up, so I probably left something out here. And so I'm going to show you the first feature of Instant SQL, which is the ability to break apart column expressions. So when I click on a column, I can break apart to get the next level of expressions, and I can also get all of the data in that level of expressions. So you could see it go all the way down to fair amount, tips amount, tolls amount, and I can like essentially keep going all the way down as far as makes sense. And this is really cool, actually, because essentially we have turned the SQL query into a sort of like giant Excel function that outputs a list of expression trees. And it means that we can actually see the flow of data through your formulas and your column expressions. So let's just go ahead and like add some data to this. Just an arbitrary amount of data number here, and here's the bottom of it. So as I like add zeros, as you can see, it updates everything in real time. And so this one feature, just the ability to break apart your columns, your column expressions, and like see the flow of data, makes debugging any kind of expression a piece of cake. Whether it's complex formula and you can hunt for the nulls and figure out why exactly that the output value is all null, or my favorite, regular expressions, which are so hard to debug. And you can actually just do this in place now without having to ever run your SQL query. Does everything you type count as a query to the database? The answer is yes, it does query the database, but because of dual execution, there's no charge. You're running, the caching step is the only thing that actually queries the MotherDuck database. Everything else is local. Right now, we're running this in the MotherDuck UI. So this is all actually in the browser in DuckDB WASM. Once the data is cached, which is extremely cheap, negligibly cheap, I would say, every query that is run on keystroke is basically free. You're just using your hardware at that point. Cool. Okay, so that's it for total amount. What else should we do here? You know what? I'm gonna go ahead and move these around a little bit and subtract them from each other. And awesome. So now I have something that looks like the total time, the total ride time. Also, isn't there like a passenger count? Passenger count, and what else? You know what actually would be interesting? Can we do total amount divided by passenger count? Nice. Okay. This looks good. I'm going to get rid of total amount as cost per passenger. All right. So I want to be a good little data engineer. So I'm going to wrap this in a CTE with data, very creative name, and go ahead and do something interesting with this. So from data, great. Those are all the columns. Select median, cost per passenger, nice, and passenger count. I'm just kind of interested in what's going on. Oh, okay, I need a group by all. Group by all, wonderful. Okay, so I've got median cost per passenger. You know what else? I'm gonna add another column as well. Select median. Oh, you know what? I want to get the median of this value up here. So now I'm going to do something, and I want you all to pay close attention to the result set. I'm going to click into this CTE. You see that? The result set changed. This result set is showing you the data inside the CTE. So if I switch back, I have seen the result set of the final select node. So this is kind of part of this parser-powered query intelligence. Wherever your cursor goes, we can actually show you the underlying data of that subquery. So this makes it super easy to inspect CTEs and actually do things with them, and then move back to any dependent node and continue the actual modeling. It's really, really cool. It's my favorite part of this. It's kind of the whole motivation. How do we make it easier to work with CTEs? So I'm just going to name this as ride time. Not doing anything fancy with it right now. You can see I can click it apart and see the two different pieces of it. Good stuff. So I'm going to switch back here and also do median ride time. And then the column, great. So fantastic. I'm seeing that I have an infinity here for cost per passenger when it's 0, which makes a lot of sense. So I don't know what kind of rides have no passengers. It's kind of funny things. Let's just filter that out where passenger count is greater than 0. Awesome. So now this is actually a new feature that's about to go into Instant SQL. I just added a where clause, and we decided that because we're building out a cache, we were applying the where clause after the cache was generated. We actually found a way to just essentially apply it at the caching step. And because DuckDB is so fast and dual execution works so well, this means I'm always going to get rows back that are relevant, which is a huge problem generally with building any kind of system like this. So now I have, I've gotten rid of my passenger count 0, since I don't think that's actually very relevant. Order by passenger count ascending. Beautiful. Okay. So these are most of the basics of Instant SQL. I haven't run the query once yet, right? I've just been typing and kind of modeling all of the data interactively, not unlike using a digital audio workstation, right? We're trying to build a system where you can just do stuff and the system reacts as fast as possible and keeps you in a flow state. It's really, really cool. So now I'm going to hope that the demo gods play nicely and show you another really cool aspect of this. So I've got this ride time here, which is just drop off minus pickup. That's great, but I want to convert this to seconds. So I'm going to do is highlight. And if you've ever used any AI tools, this is probably quite familiar. We have a feature in MotherDuck where you can just hit Command K and pop up a little prompt. And I'm going to prompt it to do something. Give me ride time in seconds, and hope that this works. So as you can see, here's the median ride time. Pay attention to this column. Yes, it worked. Notice that we are now previewing the suggestion in real time. So I didn't have to apply the edit and then run the query and then check to see if something has gone wrong. Instant SQL actually makes it easy to preview basically any AI assistant feature in real time, because it's the same underlying machinery makes this work. It doesn't matter if it's AI writing a query or whether or not you're writing it. Instant SQL will be able to actually able to run it, which means that pretty much every AI feature is about to get much better with Instant SQL. And this is just the most, like, I would say elementary kind of feature, kind of mashup, right? Like synergy, because I am not doing anything special here, but context is everything with AI. And so the fact that we have this level of control over the internals of the database means that we're going to be able to build AI features with Instant SQL that are kind of unlike anything else that you're able to see. And it's really because of this dual execution model that MotherDuck has. So awesome. Apply my change. I'm done. At any point, I can choose to run the query. And this is important. Instant SQL it's an aid to running queries. It's not a replacement, because ultimately I'm not necessarily running the data. I'm not running the entire query on every keystroke. I'm running it on a subset and getting a preview. And that preview was super useful for actually getting my query logic right. So at any point, I can hit the run button and actually get the data that I care about. Now, this is kind of a small data set. I think there's only a few million rows. So DuckDB is already incredibly fast. But any of you who have done this with, against tables with 100 million, 1 billion rows, it could take, tens of seconds, maybe even minutes with DuckDB, maybe even longer to actually run that query. So with Instant SQL, you can reduce that down to, 50 to 100 milliseconds. So that's the basics of Instant SQL. I'm targeting a MotherDuck database, but this works basically with any data source. Here's another example. This is just a, Parquet file in an S3 bucket. It's actually the same data set, actually. I'm pretty sure. It doesn't matter what the data source is. Instant SQL can instantly select TPEP pickup date time, et cetera, et cetera. You can model basically any type of data source. And this is really powerful because essentially whatever DuckDB can query can be instantly modeled. This means if you're querying Iceberg, or obviously we saw with MotherDuck database, or a local DuckDB database in the DuckDB UI, or If you're querying MySQL from DuckDB or Postgres, really importantly, Postgres, it's really great at actually exploring your production replicas in Postgres in real time. And actually much easier to do it there than almost anywhere else. As long as DuckDB can query it, it can be modeled with Instant SQL. So yeah, that's basically the long and short of it. Let me switch back to my other tab. Excellent. So where does that leave us? I want to go back to this quote that I started the talk with. We shape our tools, and thereafter our tools shape us. Now, I spent a long time in music, and I think a big part of a music education is learning about what it means to achieve mastery, and why do we try to achieve mastery with our tools. To get good at music requires a lot of deliberate practice. And practice comes in many forms. When you're younger, it's like just getting good at instruments. When you get older, it's getting more types of experiences under your belt so that you can make better choices. But practice is central to it. But mastery, I've always kind of thought of it this way. As somebody who wrote a lot of music and not just performed it, mastery is kind of a means to an end. I think the more interesting end is using our mastery to kind of push beyond the boundaries of what's possible and to explore new territories, which I think is actually a very human impulse. And so I experienced that with music. Going back to a kind of our humble little corner of the world where we talk about transforming data with SQL, I don't know what comes after Instant SQL, but for me, I hope it is a tool that can encourage people to approach mastery and push beyond it in some way. I think that's important because really the tooling in data work, I think, is in need of some modernization. So if you want to use Instant SQL, you've got two opportunities to do it. One is to go to the DuckDB UI. You can just copy this curl command and it'll just like both install DuckDB if you've never installed it, and also it'll launch the UI. And of course, sign up for MotherDuck. You'll get Instant SQL supercharged through some of MotherDuck primitives. Anyway, thank you.
Awesome. Thank you very much. Does anyone have questions or comments for Hamilton? Getting a lot of claps, so that's great. Yes, Lam.
Hey, great presentation. I had a quick question about local DuckDB. So if you're using it through the local DuckDB UI, does that caching happen in the local database?
Yeah, so actually, one of the cool things about our UI model is that it requires, both of them assume some local DuckDB instance. The MotherDuck UI uses DuckDB WASM, which essentially keeps everything in memory in WebAssembly, and then if you refresh your tab, it goes away. The DuckDB UI is a more kind of stable, but also totally separate database that's just running, or a process that's running in the CLI. So the caching layer happens in memory, in tables in memory database in DuckDB, which means that, again, every keystroke after the data is cached is super fast and super free. You don't really need all of your cores to like rewrite these queries and run them. As you can see, it works perfectly well with DuckDB WASM, but you do need that local copy of DuckDB, both for the parser and also for the ability to rewrite these queries effectively.
Other questions? Before it.
So I was wondering if you see a possible use case for, like, for example, if you have some database that you can't query with DuckDB, but you want to use like the Instant SQL functionality to like build out your query. Do you think it would make sense to like use Instant SQL to build it out and then have like SQL Glot or some other tool do the transpile to your target dialect? Do you think that's like a valid use case there?
Yeah, I think there's like a short-term answer and a long-term answer to this. So my short-term answer is if there's a way to export the data just to like Parquet even, you can easily model Parquet files locally or even Parquet files sitting in S3 or whatever. And so as long as the data is, it doesn't even have to necessarily be typed. Like Instant SQL works great with CSV files as well. The problem is if you really want type safety in the columns, it's useful to export it in a typed way. That's how I would maybe recommend doing it. And then SQL Block can easily bridge the query that you've just written. So that's my short-term answer. My long-term answer is maybe a little different, which is, I think over time, I mean, DuckDB basically has the ability to query what? I can query Postgres, I can query MySQL, I can query BigQuery with DuckDB. I can query SQLite, I can query data lakes, I can query Iceberg, and so on and so forth. I think over time, as DuckDB kind of expands its extension set of things that it can query and scan, Instant SQL becomes more and more useful for other database systems entirely. So I'm really bullish on that, and I hope if it can be queried in DuckDB, somebody will create an extension to do so, I think.
Awesome. Yeah, that sounds great. Yeah, thank you so much.
Got something in the chat. Does DuckDB support reading data out of any popular time series database, e.g. Influx? That's a good question. I don't know the answer to that. But if your database can export data as Parquet files, then DuckDB can very easily handle it. And actually, just last week, DuckDB 1.3 came out. And with 1.3 comes essentially a rewrite of its Parquet reader. So now querying Parquet files in DuckDB is like screaming fast too. It's not quite as fast as querying DuckDB tables, but it's pretty close. And so really, and they did that, I think, in part because today they just released essentially their Iceberg kind of competitor called Duck Lake, which requires, where often is used, Iceberg is often used with Parquet files. So it makes a lot of sense that they would invest in their Parquet reader a lot more. So yeah.
Pastor.
Yeah, so does DuckDB support NoSQL?
Does it support NoSQL?
Yeah, so can I make queries on NoSQL database or?
If there is a scanner, a DuckDB scanner for a specific database, that would be, excuse me, the way to do it natively. If that NoSQL database has a way of outputting its semi-structured data in some way, as JSON or otherwise, DuckDB actually has pretty decent JSON querying. And so you can actually query data in a NoSQL database, but it would require you to export first. That's always an option, I think, with DuckDB or really any database system. But to my knowledge, I don't think there's I don't know of any extensions that directly work with known NoSQL databases.
Okay. Hey, can I use it with VS Code, for instance, like DuckDB or?
I think you can. I don't remember the name of the extension, but there's a popular SQL extension that has a DuckDB mode of some kind. I don't remember what it is, so I can't give you the recommendation.
No worries.
You could also try the DuckDB UI, and while it doesn't have like all of the functionality of VS Code, almost by design it doesn't. One thing that it does have is a lot of really helpful data viz powers that VS Code does not natively have. And generally, I think you see this a lot. Like, why would you use something over VS Code? It's if its feature set is better for that specific domain. And one I think area where data UIs are different than IDEs is data visualization and data exploration tools. And so we have a few of those in the DuckDB UI and the MotherDuck UI.
Okay, thank you.
Jenna had a question in the chat there, Hamilton.
Is there some way you see Instant SQL being used to enable drill down in dashboards when the dashboard doesn't quite answer the question you want to ask and a technical just wants to tweak or drill down an underlying data? This is such a great question because, and it's an area that I feel very generally bullish on with DuckDB. So my background is in data visualization and building BI tools. And I came to MotherDuck because I was really excited about the possibilities of working at the like data infra layer, but my mind still kind of goes toward like BI use cases. And so one thing that we're hoping to work on at some point in the future is the ability to do kind of something very similar to this, which is like enabling better drill down just in our column explorer feature. So the column explorer is a way to get diagnostics on any table or result set. You see all the shapes of the distributions and the null percentages and stuff like that for all of the columns. And it's super performant because of DuckDB, basically. And one of the things that we'd like to actually do is use the detail plots where you click on a column in the column explorer, it extends down, you see a bigger version of the plot, and enable basically kind of scrub to zoom, kind of filtering capability, drill down capabilities there. So I think that DuckDB itself is already really good at this part and doing it kind of in an interesting way. Now we're also working on something that I think could potentially, this is speculative, but it could be potentially pretty revolutionary, I think, for the BI use case in general. And that the problem of caching data actually has motivated maybe a more interesting primitive. So we have this concept, this new object called a result. It's like a table or a view, but it allows partial lazy materialization of a query. And that's great for like showing result sets and things like that. But as you can see, there's like a, when you have a SQL query with like a bunch of CTEs or any complex transformation, there's actually like a DAG of relationships between all of the nodes of a query, all the subqueries, right? A CTE could depend on another CTE, and the final select statement could depend on that CTE. And we actually think we may be able to use this new result object to chain together definitions so that wherever you request data, you're able to pull down enough rows through the system, and the database basically optimizes all of the details. So why is that important? Because it's possible that we may be able to change this just from like looking at the like scanning down in these results to actually creating table samples. And if we were able to create table samples, that means that you can create unbiased estimators for any aggregate, which might actually enable a faster version of most dashboards. And so this is kind of like groovy, mind-bending stuff. But I think we're able to land this. It essentially means we could speed up virtually all dashboards, including the drill down aspect of dashboards, kind of optimistically. And that could be really, really cool. Now, the primitives of Instant SQL are really for querying, but I think that the underlying ideas are much richer. And obviously, as you can see, I don't I don't have a fully formed version of this yet, but this is an active area of research for us. And we really think that Instant SQL could just basically change how BI feels across the board.
Got a question in the chat here from Javier. What is the roadmap for integrating Instant SQL into data grip?
It's a great question. We don't, essentially, I think the question is, what's the roadmap for for being able to integrate Instant SQL into anything, and whether or not data grip is a target is maybe a separate question. We're not sure yet. We have the goal to open source components of the DuckDB UI and eventually all of the DuckDB UI, but we do not have a firm roadmap on that, and there's a lot of work and effort needed just to get that out the door. Instant SQL is an open question. We're not sure where we're going to draw the boundaries in terms of open sourcing it quite yet. People at MotherDuck differ on this topic because it's always a complex thing figuring out what you give away and what you keep. I'm excited to see the ideas of Instant SQL apply everywhere, and I would love it if this idea permeated all of the data world, because I think we really deserve tools that work faster than what we currently have. And so much of the other tools we use in our lives and in other industries, and even ones that we use, feel much more instant, right? And for some reason, data work has lagged behind everything else. So I would love to see a version of Instant SQL everywhere.
Oh yeah, I could think of using notebooks, for example. So,
yeah, definitely.
Having to run the cell every time, it sucks. Cool. Any other questions for Hamilton? All right. Well, thanks for your time. Really appreciate it. Killer demo and great presentation as well. So, Suba, you have your hand raised.
Oh, maybe
okay. False alarm.
I do that all the time. I accidentally raise my hand instead of clapping.
Can we ask about Duck Lake?
I can't promise I can answer everything. We got a preview at MotherDuck. We got a preview on Duck Lake before it came out, but I'm not maybe the most sophisticated person at MotherDuck to answer those questions.
Okay. I just reached out to Hannes to see if he wants to come do a lunch and learn. So
That's a great idea.
stay tuned. I know he's busy, but well, sick. Thank you very much. Are there any upcoming events that you'll be at next week at Snowflake?
Oh, yes, I will be. If you're at Snowflake, come to the MotherDuck party. It's on Monday. I'll be there. I'm happy to talk more about Instant SQL or anything else. And it'll be a good time. We throw a good party.
Yeah. So last year it was fun. Good time. So awesome. Well, thanks everybody. I think tomorrow we have an event. Let me see, with Aaron Hunsaker, I believe. He's going to talk about resumes, making them look great. He's the head of data at Carhartt. So anyway, if you're interested in making sure your resume doesn't suck when you send it to people, please attend. And again, thanks Hamilton a ton. Great job. So really like it. Can't wait to nerd out on this some more. So
yeah. All right. Thanks for having me.
Anytime. All right.
Bye, everyone.
Yeah. Okay. Thank you.